Hello, everybody, and welcome to GlugNet. My name is Stephen Ball, and I am the president of GlugNet. Tonight, we are pleased to welcome Matt Hess, who will be talking about getting on the bus, the Azure Service Bus. Before we get started, a little bit about us. We are the Greater Lansing User Group for .NET developers, based out of Lansing, Michigan, as pictured here on this map. Our meetups are on the third Thursday of every month, free and open to the public to attend. The best way to find out about what's happening is to join our meetup page, meetup.com/glugnet. There you'll get email blasts when we schedule something new, and you can see what's coming up next. Or we also promote on various groups on LinkedIn as well. Meetups are typically recorded and posted to YouTube by Sam Nasser. You can find his channel at Sam Nasser MVP or using the QR code here on the screen. A few housekeeping items before we get started. We are always looking for lightning talks before our featured presentations. If you have a topic that you can do 10 to 15 minutes on that you think our group would be interested in, you can either let myself know or Joe Kunk, and we would be happy to schedule you before our presentation. Tonight's presentation is designed to be interactive, so we encourage questions or comments from the attendees. You can do that a number of ways. You can either come off of mute and ask your question, or there's also a chat feature in GoToMeeting that we will be monitoring for questions, and we'll feed the questions to Matt that way as well. We just ask that unless you're answering a question or asking a question, if you please stay on mute. That way we can all hear his presentation and enjoy it. At the conclusion of tonight's presentation, a survey will be made available to all attendees. We're looking for feedback in two particular areas. First of all, as a group, how did we do getting the word out about this event? And second of all, what did you like about the event? What didn't you like? All that feedback is completely anonymous. It's rolled up, summarized, and sent to Matt. So whenever he does this talk again, he can improve it. So we would very much appreciate if you would fill out with your honest feedback so that we're doing better as an organization and this talk can continue to improve as it continues on. At this point, I would like to thank our sponsors for the evening, NIS Technologies, who's providing this go-to session, and the .NET Foundation for their financial support of GlugNet. And now it is time for our featured presentation.
I'm excited to get to come back to GlugNet and talk to you again. I got to do a few lightning talks over the summer, and now you get a feature-length presentation. And for a couple of brave souls on the call, particularly Stephen and Joe, this is not their first time watching it. So you guys are amazing. I hope it's not terribly boring having to see it again, and you can see if I actually give the same talk twice. That'll be funny. So the talk is and by the way, I'm presenting on a laptop, so I normally can see people's hands go up or see people's faces, but I can't right now because I just have the one screen. So if you want to stop me and get my attention and ask a question, just either use the chat, like Stephen said, and he can let me know, or just call out. I love questions, so don't hold back. Okay, so we're going to talk about Azure Service Bus. Before I launch into it, just a couple acknowledgements. First off, I want to acknowledge my father, Larry Hess, who passed away this last summer at the age of 84. And he had just turned 83. And I just really lucked out in the dad department. He was an amazing man, an amazing father. Daddy, I miss you so much, and I love you, and I'm grateful for everything you gave me. I also want to say thank you to my employer, CG Infinity. We are a consulting shop out of Plano, Texas, and it's a enlightened, good place to work. It's a great work culture, and they've been very supportive of me and these kinds of activities. They know that I'm doing this. They provide a little financial support, and they sponsor the Albuquerque .NET User Group. So thank you, CG Infinity. We are hiring for people on-prem in the Dallas or Houston areas. You can go to our website, take a look if you want. One thing I like to address before I get going is like, why am I even here? Why am I doing this? Why did I fly to Detroit yesterday and give the talk? So, you know, this is community service. This is volunteer work. C# has been very good to me, and I'm trying to pay it forward. And people sometimes ask this question, you know, about software development. Is it an art or is it a science? And to me, it's neither. It's a craft. It has its artistic side. There are people out there doing true computer science. They are brilliant. Sometimes I don't know what they're talking about. But for me, week in and week out, year in and year out, I get paid to build stuff that works, that's reliable and robust and performant. And so that's what we're doing. We're focusing on the craft of C#, and I'm just hoping to help people level up and just get a little better at that. So that's my motivation. That's why I'm here. And if I can spark a little curiosity or give a few of you a few new ideas, then that's success. Okay, so what is Azure Service Bus? First, we can give you kind of an academic definition. Azure Service Bus is Microsoft's cloud offering for developing message-based applications. So what do we mean by that? We're going to dig into that a little bit. But first, I'm just curious if there's anyone on the call who has used Azure Service Bus or another similar technology like Kafka or RabbitMQ, or maybe the older Microsoft technologies like MSMQ. And I can't see you, so if you have, just say yep or make a noise or something.
Yep.
At least one. Okay.
Me too. Active MQ
right,
long time ago.
Cool. So if you've done this, that you know, there's going to be some similar stuff. But this definition is a bit academic, so we got to dig into it. But first, let me ask the question: like, what kind of bus are they talking about? This service bus? You know, is it a double-decker? Is it an old school bus? What are we talking about? And I kind of wish they hadn't called it Azure Service Bus. To me, the term bus is a little confusing. Like in electronics, a bus is the thing that shuttles data like between the CPU and the RAM, and it's extremely high performance. It's hard-coded, point-to-point data transfer. And when you're dealing with a messaging platform like Azure Service Bus, it's not high performance. It's asynchronous, in fact. And it is not hard-coded. It's somewhat flexible. Its purpose is actually to decouple things, not to couple them together. So an electronics bus couples things together. In software engineering, a message-based system helps you decouple. So I don't know why they called it Azure Service Bus. It's a catchy term. It's an industry term now for some reason. I just think of this as Azure queues. And as you'll see, when we dig in here, you're going to see queues and messages. That's what's inside of Azure Service Bus. It's queues and it's messages. So before we dig into the specifics of Azure Service Bus, what is a messaging-based architecture for? And as always, I want to approach these kinds of abstract questions by talking about food. I love food, so let's talk food. So what we're going to talk about first is an example of a non-message-based architecture. This would be like a standard synchronous architecture, the relationship between you and a snack machine. So let's say you're at your desk and you're working, and you're feeling a little bit hungry. And you think, oh, I know what to do. You get up and you walk down the hall to the snack machine. You put in some money. You make a selection, and out the bottom pop your Munchie Crunchos. and you grab them and you walk back to your desk and you're satisfied. So that is a synchronous interaction. And if we were to do a UML sequence diagram for this, you would see this is a tightly coupled system. So you, the customer, walk up to the vending machine and you make selection and it returns a snack to you. So think of it as software. The customer is the client, the vending machine is a server, maybe it's a REST API, I don't know. And you call an endpoint, make selection, and you get snack. Or maybe you get 404 snack not found, or something like that. In any case, you get your response right away. And this is how most software is written. When you call within C#, when you call from one function to another, it returns, right? It's tightly coupled and synchronous. When you call a REST API call, you get a response back right away. So that is the normal way of writing software, tightly coupled and synchronous. So let's compare this to a different scenario. Let's say now you've been working all day and you're really hungry. So if you were with me in Albuquerque and this happened and we were really hungry, we would drive down to the end of Lomas Boulevard and we would go to Duran's Central Pharmacy and get some of the best New Mexican food you can get. And what would happen is we would walk in, we would place an order at the counter, and we'd sit down, and eventually our food would come. And the way that process works is we give our order to the person at the counter. They write it down. They put the little piece of paper on that metal spinny thingy on the wall between the counter and the kitchen. Somebody back in the kitchen grabs that ticket off the wall, off the spinny thingy. They prepare your food, and then it gets brought out. So that is a decoupled system, and the spinny thingy is the queue. So let's do a UML sequence diagram of that. And now we've got 4 things in the diagram: customer, counter, the queue, and the kitchen. So you're the customer, you walk up to the counter, you place your order. And then the counter person enqueues your order. The message is the actual order on a piece of paper. They put it in the queue, the silver spinny thingy, and then someone in the kitchen grabs the ticket off of that. That's dequeuing it. They prepare it, and then it gets run out to you. So this is a decoupled, asynchronous, or message-based system. So why are restaurants built this way? Every restaurant we go into is built this way. Why doesn't the counter person just cook your food? You could walk up and say, I'll have the enchiladas, and that person could just cook it for you. So the reason the counter person doesn't cook the food is that everything about taking an order, the equipment, the environment, the training, the whole thing is just completely different than what you need to prepare food. The equipment, the layout, the training, the staffing, and importantly, the scaling. And I'm going to talk about that a little more. So you really want completely separate implementations of your counter service and your kitchen service. You don't want a monolith there. You need them to be separate. So let's talk about scale factor or scaling. If this is Thursday afternoon, things aren't too busy, you might have just one person working the counter and maybe a couple of people back in the kitchen cooking the orders. And so it's kind of a 1-to-2 ratio, and it's balanced. But on Sunday, at the Sunday brunch rush, when everybody wants their huevos rancheros, you might have 3 people at the counter and 7 or 8 or 9 back in the kitchen cooking all that food. So the scale factor is different. You've got different technology, tools, training, equipment, tech stack, and scale factor. So this is why we decouple systems. And a message-based architecture is for the communication between the pieces of this kind of enterprise decoupled system. And we work with this all the time in our real lives. Think about e-commerce. You know, you found some socks that you really have to have for Thanksgiving. And so you go on your favorite e-commerce site and you place an order. Well, when you order that, there's a message, it gets put in an order system that sends a message to the email system to send you a confirmation, and it sends a message to the warehouse to pick and pack it, and that sends a message to the shipping function to ship it, and then there's another message to the email system to notify you that it got shipped, and then another one that it's been delayed, and then there's probably another message off to some accounting system to like put entries in the ERP, and maybe there was a credit card transaction that needs to get run or collected. I mean, there are all these different systems. They're not tightly coupled together. They talk via messaging, via queues. So Azure Service Bus is a guaranteed delivery, FIFO, enforcing industrial strength way of passing the messages between these kinds of systems. That's why we use this technology. That's the problem it solves. So before I move on, I do want to let you know that we did actually get the enchiladas, and we got them Christmas, red and green. And you may not know this, but in New Mexico, many places have a state bird, a state flower, a state motto. Well, New Mexico has a state question, and the state question is red or green. And in this case, we couldn't make up our minds, so we got both. And it's delicious, and someday I hope you can come join me for a plate. Okay, I don't know if you had dinner already. If not, you might be hungry. Sorry about that. Okay, so let's now get into the details of Azure Service Bus. And we've got some prerequisites, some things to help us get set up. So this is Azure, so you need an Azure account. You need to know how to log on to the portal and run the CLI. You need a resource group created so that you can pay your bill. So that assumes you've got all that set up. The first thing is you need to create what's called a service bus namespace. So a service bus namespace is just a container. Your queues are going to live inside of that. So it controls security, like authentication to your queues, and it's also kind of the unit of billing. So when your bill comes, I think it breaks it down by the various namespaces that you have. So to create the service bus namespace, what you see there is some Azure CLI, a command line that will say, let's create a namespace using a resource group, giving it a name, and telling it where you want it located. So and once you've created it, if you go browse on the portal, you'll see your namespace was created here. I called it test bus namespace. So that's the first thing, create a namespace. Then we need to create a queue to work with. So here's the Azure CLI, queue create, specify the resource group, specify the namespace, and give it a name. And once your queue is created, you'll see it. It's active, and it has no messages, no active messages, no dead letter messages, no scheduled messages, but it's ready to go. Now we're going to be writing some C# code. So if this is the way you're working with Azure Service Bus, you need to install the Azure Messaging Service Bus NuGet package. And in any code unit where you're doing Azure Service Busy stuff, you need to say using azure.messaging.servicebus. So those are your true prerequisites. There's one other thing I like to include here, and this is instantiating your service bus client. So if you've done some SQL programming, you know that pretty much the first thing you do is you create and open a connection, regardless of what you're doing, running stored procedure. It doesn't matter, you have to have a connection. Well, a service bus client is sort of similar to that. It authenticates you to the namespace, and it also is sort of a factory object then for creating the different things you need. So there are a couple of ways to instantiate a service bus client. This one is a very production code looking way because it's using the default Azure credential construct, which ties in with Microsoft Entra ID to kind of run through a cascade, an authentication cascade. So in production, you might see this where we say, okay, I'm going to get my credentials somehow. I'm going to set up some options. In this case, I'm choosing the high performance AMQP WebSockets transport. And then I call my service bus client constructor, giving it the namespace, the credentials, and the options. So that's a good way to do it for production. It's a little bit awkward for just development and testing. So for that, we can use a simpler way, which is just to use a connection string in much the same way that you would a SQL connection string. So these connection strings are created for you. You can browse on the portal in your namespace, and you can reveal them and then copy and paste them and use them. In this case, I've stored it in app settings. You can also use a little command line to print out all of the different primary connection strings you have for that namespace. So with a connection string in hand, you can instantiate your client by just calling a different constructor, which takes just the one string. So these both will result in a usable service bus client. That happens for everything we're going to do. So I include it as a prerequisite. It's often common to just create a helper function that gets you your service bus client instead of doing it all the time in the code. Okay, that's our prerequisites. Any questions so far before I move on? Okay.
All good in the chat.
Sounds good. Yep. Okay, so before we actually send and receive any messages, oh, no, that's what we do next. Hey, look, I've left myself hints in the form of the titles of the slides. That was clever. So what we're going to do next is we're going to send a message, just a simple message, and we're going to receive that message, just fundamentals here, nothing fancy. So to send a message, we create our service bus client using, in this case, the connection string. We need to know which queue we want to send it to. And then we're going to create a service bus sender by calling client.createSender and handing it that queue name. And then we'll create a message, in this case, just very simple, using the constructor where you just give it the message, subject, and body right there. And then we await sender.sendMessageAsync, passing in the message. So after we do that, if you were to refresh the portal screen we had before, my first queue would now show a message count of 1 and active messages of 1. So we sent a message. Let's receive a message. Again, we create a service bus client. We figure out which queue we're going to receive from, and then we create a service bus receiver by calling client.createReceiver. And then we call await receiver.receiveMessageAsync, which will return a service bus received message if there is one in the queue. Now, if there is not a message in the queue, this call to receive message async will eventually time out, and you'll get null. You get a null message back. So if we did get a message, we can check, did I get a message? And then we can do stuff. And one of the things we're going to have to do is complete the message. Now, this is complicated, and I'm going to spend a lot of time on it later. But for now, I just wanted it here for completeness, just to illustrate the point. Okay, so we sent a message and we received a message, and the Azure portal has some lovely ways for you to monitor this kind of activity in these graphs. And you can see the send and the receive events here. So we sent a message and we received a message. It's important to just refresh yourself on how queues work. So a queue is a first in, first out data structure, a FIFO data structure. So if I send 3 messages, M1, M2, M3, and then a receiver comes along and receives it, it's going to get M1, first in, first out. And unless you, if you're careful and just write vanilla code, your Azure Service Bus queues will enforce guaranteed delivery and FIFO ordering. So you can use it just like you used to use MSMQ. If anyone did that, that also, it was the same thing, right? The messages came out in order, and once you were guaranteed to receive it once and only once. So that is all enforced for you. Now I want to put another slide up here. People have heard the concept of pub sub. publish and subscribe. And if you've used Kafka, for example, or if you've used other technologies like Salesforce Event Hubs, you maybe have got some experience with this. So Azure Service Bus does support a pub/sub pattern somewhat. It is not nearly as flexible and robust as what you get in some other technologies. And here's basically how it works. So if you want to have multiple receivers of the same message, instead of creating a queue, you'll create what's called a topic. The CLI is the same. You just call create topic and you give it a name and a namespace. And then for that topic, you have to explicitly set up multiple subscriptions. So in this case, I've created a topic called My First Topic, and I've set up several subscriptions for it. And you can see there's a subscription count there. In this case, it's 0 in my screenshot, but in my illustration, it would be 3. And so when the sender sends the message, they send it to the topic, and basically each subscription gets its own copy of that. So when you look at the topic, it doesn't have any counts. There's no message counts like we saw before. But when you look at the subscriptions, you see message count, active messages, dead letter messages. So in a way, this is just like a multicast queue. You send it once, and it creates multiple copies in the various subscriptions. So this is very different than like an event hub where you can publish an event and people can go get it after the fact, and it stays there, right? You could receive it multiple times, and new subscribers can come along after you've sent it, and eventually it times out. In this case, if you weren't a subscriber when the event was sent, you're not going to get the event. It is possible through code to self-subscribe to a topic, but it's just much more structured, and it can cause a little confusion, but it is simple. It's simpler than most people think. So again, if I had sent a couple of messages, M1 and M2, they each went into the subscriptions, which is each like a queue. And then when this receiver receives it, it gets its copy of M1, has no effect on any other subscriber. So topics are cool. I don't want to spend too much time on this topic. It can run away a little bit, but I did want to let you know that exists. Okay, so those are your fundamentals. Set up a queue or a topic. And if it's a topic, you need some subscribers, and then you can send and you can receive. I'm going to talk about message payload, but first, any questions so far? Feel pretty good?
Chat looks good.
Thank you, Stephen, for letting me know that you all still alive, and I'm not just talking to this conference room. It's a spooky thing. After last night where it's live and you get so much feedback, it's a little weird just talking to the computer, but okay, let's keep rolling. So next we're going to talk about message payload. So we sent a message and we receive a message, but I want to encourage you to spend some time thinking about what's in these messages, what kind of messages you're sending and why. And I'm going to introduce a distinction, some terminology here. I make a distinction between what I call heavy messages and light messages. These are Matthew terms. You're not going to hear anybody else use them. By a heavy message, what I mean is, my definition is, the message contains everything that the receiver needs to take action. And a light message is more like an event or a signal, a notification. Something happened, but if you're going to take action, you probably need to gather more info. It doesn't have everything. So sometimes these are called stateful and stateless is another way to think about it. So to explain that heavy message, let's take a real world example. So let's say that you are a salesperson and your job is to prepare bids. And the way it works is you prepare the bid and your boss has to approve it and review it before it gets sent out. So now let's say this is happening in 1998. So you're composing your bid using WordPerfect and you're printing it out on the dot matrix printer. So you type it out, you print it, you put a staple in it, then you go get a Post-it note and you stick it on the stack of paper and you write on it, "Hey, Todd, here's a bid, please review." And then you walk down the hall and you put it in Todd's inbox, in his metal wire inbox. And then hopefully Todd comes back from playing golf someday and pulls your bid out of the inbox, reviews it, and you guys go make a lot of money. So in this case, the queue is the inbox, right? The metal wire tray. The message is that entire packet, the printed out bid, all 12 pages, stapled together with the Post-it note on top. It's the whole thing together. That's a heavy message. It is fully self-contained. When Todd gets that, he doesn't have to come ask you for it. He doesn't have to go to the file cabinet to get it, or the mailroom or whatever. He's got it. It's fully self-contained, and it can be acted on right there. So now let's fast forward, and now we've jumped forward to the present day, and you still have the same job, and Todd is still there, except you're all using new technology. So when you compose your bid today, you're probably using some bid preparation software like a CRM. Maybe it's Salesforce. And so you type out your bid, and as you're going, you're clicking save, and it is saving into some repository or database of some kind. So your actual bid is down there in the database. And when you're ready for Todd to review it, you click a button called Ready for Review or Submit. And what happens is Todd gets a Slack notification that goes ding on his phone, right? It's just a notice. Oh, hey, there is a bid ready for review. And then he's like, cool, let me finish this round. He goes back to his desk, sits down, and when he reviews it, it retrieves it from the database. So the message in this case is just very lightweight. It's like, hey, here's, it maybe as the date, maybe the bid number, maybe the customer name, and the total amount, who submitted it, and that's it. 5, 6, 7 fields, not the entire bid. So that's the distinction. The first one is heavy. It has everything. The second one is more of an event. It's very light. It's just a notification. So I have used both. In fact, I've used both in the same system, right? The same overall system. It just kind of depends on the relationship you have between the sender and the receiver and how your system is architected. There are pros and cons. Heavy messages allow complete decoupling between the components. They don't have to share anything at all. The downside is they are stateful, which means they could go out of date. And if things have changed, you now have an old snapshot, and you have to somehow send a superseding message that says, no, this is newer. That can be a little tricky. When you use kind of the eventing model of notifications, it's very natural to many of us, but it does create a little bit of a coupling, right? Because they're both sharing the same database. So to a purist, maybe you don't want these two systems to have to share a repository. And maybe you solve that by setting up a callback API so that the reviewer can somehow call back and get what it needs from the system that sent the notification. So you preserve your decoupling through an API that goes the other direction. All right, so that's just some stuff to think about. With Azure Service Bus and C#, you can easily implement both patterns. So here's a little class, public class bid, that has these fields, bid ID, bid date, customer description amount. And here it is in use, where we say, make a new bid, bid number 1,000, current date time, Acme widgets, plastic pellets, 225 million of them. And then we can create the message one of two ways. The first one allows you to use your JSON serializer of preference. You could use Newtonsoft, you could use the .NET one. So you're going to create a new message just passing in a string. This is like our initial hello world message, my first message, because you are taking that bid class and you're just serializing it to JSON. And the message doesn't know that it's an object. It just takes your JSON and there's your message. A cool thing though is when you call the message constructor, you can set some properties in your property initializer with your property initializer syntax here. And one of them that you can set is the body, and the body will accept an object. And if you pass an object instance to the body like this, then it will automatically JSON serialize it for you, which is very cool. So I like that second syntax very much. Now, what if you want to do the heavy message? Well, here you go. Here we are reading our document bytes by calling file.readAllBytes async from some path. And then when we create our new message, we can say the subject is that little bid object. That's like the post-it note now. And the body is new binary data passing in the bytes. So now you've got a message that contains the entire blob, the whole document. This is your heavy message. And they can, depending on the transport and how your system is configured, these can be huge. I think you can get up to like 100 megs in a single message if you want to. So this sometimes elicits some conversation about which should I use and why. Ultimately, it's going to be up to you and your use case to decide what's most appropriate. I just want you to think about it, to understand you have some choices to make here. Now, the next thing I'm going to talk about with regard to the messages themselves is correlation IDs. And if you do not remember anything else from this presentation, but I taught you what a correlation ID is, I did something really good. These are very important. So go back in your mind to that like e-commerce solution where you've got an order service and an inventory service and a warehouse service and a shipping service and an email service and an accounting service, all these different pieces. And there's messages going around. Well, it can be very difficult to trace the full journey of an order through that. You placed an order, great. Which message to the shipping system relates to which message in the accounting system, relates to which email notification. It's very hard to tile those together, especially since those different systems probably have different logging mechanisms. They may not be logging to a shared log. And if you have a log drain that can suck them all up, that helps, but you still have a problem of correlating them. That's what correlation IDs do. It's a piece of data, just an ID that's stamped on every single message in kind of the larger event and allows you to correlate them. So the way this works is the first link in the chain, the very first service, it is going to have to create the correlation ID. And I usually use GUIDs like this, GUID.NewGUID.toString. And then it assigns it to the correlation ID, and then that message gets sent. And then every subsequent hop needs to read the correlation ID and use it in the log messages. And then if there is a next step, include it in the message to the next system. So it places a little burden on each step to understand we're using correlation IDs, and you log them and pass them on. And then it is a thing of beauty. It's so great. I worked on a project. We were using Datadog, which is a log drain. It was pulling in all the logs from all the services. I could go into Datadog and do *:, and paste in a correlation ID, and it would pick out the 64 messages related to that, that sort of event across all the different services and let me just read sequentially the entire journey of that thing. So correlation IDs are great. And as evidence of how important this is, Microsoft gave it a top-level property in the message object, which only has 6 or 7 public settable properties. So that's how important it is. So I encourage you, use correlation IDs. All right, our next, now we kind of get in the nitty-gritty, right? We've covered why would you want to build a service bus, a messaging system in the first place. We've talked about the basics, how you get set up, how you make a queue, and how you send and receive. We've talked philosophically about like what you want to put in these messages and to use correlation IDs. Now we're getting into some of the real technical complexities, all the different buttons and knobs and widgets you have for controlling the behavior of the system. And this is where it gets a little complicated. So the first sort of option you have is the receive timeout. You may remember way back when I told you about how to receive a message, we called receiver.receiveMessageAsync, and I said it may or may not return a message and it'll time out eventually. Well, the default timeout is 60 seconds. And so if you want to control that, you can make a time span and pass that to your call to receive. And in this case, it'll only wait 5 seconds before moving on. So that's important to know about your receive timeout. The next thing is your receive mode, your service bus receive mode. This is probably the trickiest one of all. So we're going to spend a good amount of time on it. So you have 2 receiver modes. There's one which is called receive and delete, and the other one is called peak lock, receive and delete or peak lock. Peak lock is the default and most commonly used. It's also more complicated. So I'm going to teach you receive and delete first, just because it's simple and easy to understand and we can move on from it. So let me just kind of walk you through this story. So, hey, Stephen, I'm waving my hands and talking. Can people see me as well as the slides?
Yes, we can.
Okay, great. Because this is a part of the talk where talking with my hands really helps a little bit as I try to tell this story. So when you send a message, what actually happens? Well, you send it, and then somewhere in the Azure cloud, a database record is created somewhere. So there, now you've got this message, which is just kind of a record in some database in Azure. So what happens when you receive it? Basically, when you receive it, you get a copy of it, right? It's still there in the cloud, but you've been given a copy of it. And the question here is, what should happen to the copy in the cloud? And with receive and delete, the behavior is as soon as it is confirmed that I received it, as soon as that worked, then it's deleted immediately. So as soon as I call await receiver.receive message async and I get a message back, it's gone from Azure, permanently deleted. So this is very simple. It's how MSMQ worked in the good old days. It's what I was used to, which is you receive it once, you get one shot, that's it. So this is very simple and easy to implement. To do it, you do have to specify some service bus receiver options where you say your receive mode is receive and delete. And then when you create your receiver, client.create receiver, you pass in the queue name and the options, and then it will behave that way. So that's simple. You get no retries. It just, you receive it and it's gone. Receive once. Peak lock allows some kind of retry mechanisms, and it's pretty interesting and it's a little complicated. So with peak lock, what happens? So the message is at the server. We receive it and we get our copy. So far, they're the same. But the message does not immediately get deleted from the server. What happens instead is the Azure system basically starts a timer. Tick, 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 tick. And it marks that message as locked. It puts a lock on your message and starts an expiration timer for the lock. So when that message is locked, it's sort of in the queue, but not in the queue. It's invisible. So if you had another thread that went and did a receive action at that moment, you would not get that message again. While the message is locked, nobody else can receive it. So it's there, but it's locked away. And then the timer starts. And then it is up to you, the receiver, to do what I call a completion action. And that's where you tell the server, okay, here's what I want you to do with this message. Delete it or something else. So you have 4 completion options. The first one you can do is you can complete it. You call complete message async, and I'm going to rip back through the slides. You may remember way back here in our initial receive example, I called receiver complete message async, and I promised you I would talk about it. So here we are talking about it. So you can complete it, and that causes it to be deleted. So in that case, you received it, I got a copy, it was locked, the timer started, I called complete, that tells the server you're good to go, and it deletes it. So that's what completing a message does. It's removed from the queue. And this is what you do for normal, successful message processing. Hopefully, 99.9% of your messages, you receive them, they go well, and you just complete them, and that's it. So what about these other ones? Well, you have three other options. Dead letter means remove it from the queue and put it in this secondary special queue called the dead letter queue. So I received it, I have my copy, there's a copy on the server. If I call dead letter message async, it is removed from the queue and it's just put in the dead letter queue. So this is used when the message is not processable. Okay, it's a poison message, it's no good. You don't want to retry it, you just want to get it out of your way. Now, it is possible to replay messages in the dead letter queue using the Azure portal or the CLI or various third-party tools. In general, I would say if you find yourself replaying the dead letter queue, then there's probably problems that you need to address because you really don't want messages going into the dead letter queue unless they are truly undeliverable, like truly it's something you're not going to process. So that's what dead letter is. The third one, abandon, means like that. It goes like this. All right, the message is in Azure, you receive it. So it locks it, and then you say, I'm abandoning it, and then it just unlocks it. So basically, it magically reappears in the queue at that point. And if you received again, you would get it again. So abandon doesn't mean abandon from the server perspective. It means abandon from the client perspective. Like, I don't want that baby. So it goes back in the queue for someone else to pick up or for you to pick up later. So that's how abandon works. Another thing that happens is when you abandon it, it increments a counter, which is your retry counter. You don't get unlimited retries. So this is used when you want to retry the message. Basically, you've realized that the message might be able to be processed in the future, so you want to put it back in the queue and try again. That maximum number of retries is configurable. The default is 10. When the message hits that max, then the next abandon sends it to the dead letter queue. So let's say you've gone with the default and you receive it and abandon it. That's 1. You receive it and abandon it. That's 2. 3, 4, 5, 6, 7, 8, 9, 10. On the 11th, I think it is. I don't know if it's the 10th or the 11th, but when you receive it that next time and abandon it, it goes to the dead letter queue instead. Okay, so it will eventually fall out of the queue. There's a fourth one called defer, which technically puts the message back in the queue, but it's marked as deferred, which kind of hides it away unless you have some special sauce with the sequence number and special methods. It's very complicated. I've never actually used it in production. I don't really know of a use case yet. Maybe at one of these talks, somebody will say, hey, Matthew, here's what that's for, or that really helped me in this use case. But right now, to me, it just creates complexity. It creates these message ordering puzzles that you have to solve. And honestly, I haven't found a use case. So it's there for completeness, but I don't use it. So your main options are going to be complete, dead letter, and abandon. So what happens if the peak lock expires, right? Remember I said when you receive the message, it starts that timer, tick, 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 tick. And let's say that the minute has gone by and you have not completed, dead lettered, abandoned, or deferred it. You have not done a completion action. So what happens? Well, the Azure says that person went away, they didn't come back in time. It's treated as an abandon. So the message is unlocked and the counter is incremented. And if it was your 10th or 11th abandon, then it dead letters. So the timeout is just like abandon. So you can control a lot of these behaviors. For example, the max delivery count of 10, you can change that. The message lock duration is 1 minute. You can change that. And I recently did a project where we needed to increase it. And here's why. So one of the services, what its job was to take this message, it was actually a stateful message, really big, kind of a lot of data, and it was supposed to do anywhere from about 10 to 40 updates in a Salesforce.com org through the Salesforce REST API. And what we were finding is that we were getting quite variable performance out of Salesforce. If it was the production environment on a good day, it was quite fast. But if they were having a bit of a slowdown, it might be a little slower. And if we were in the lowers, like one of our test sandboxes, it was very slow. So what we did was we said, you know what, let's just push the lock duration to 5 minutes. Give ourselves a little headroom. Under normal circumstances, it was taking 10 seconds. But under some of these other circumstances, it might take a minute or a minute and a half. So we just gave ourselves more headroom. So you can control that. All right, so that was peak lock. Let me just pause. Any questions or conversations about peak lock so far?
Nothing in the chat.
People are either have fallen asleep and died, or this is all making sense. But it is a little complicated. You know, this took me definitely a few tries to really have a good mental model of what was going on here. Okay, so now let's get into the real world. Like in those examples I gave you, we sent a single message and we just received a single message. That's not real. You need to build a kind of industrial strength receiver. And there's some patterns you can follow for building your receivers. And the first one is your basic message pump. So this is a very standard common software engineering pattern. A message pump is basically a long running loop that listens for messages coming in and does something with them. So in this case, we've implemented a full message pump, internal static async task message pump. We've passed in a cancellation token. So this implements what's called the cooperative cancellation pattern. Did I present that in a lightning talk to you guys at one point? I don't think I did.
I messaged you did.
I did. Okay, cool. So I do have a YouTube video on this. It's really great. The idea with cooperative cancellation is shutting down a long-running process gracefully, like saying, please stop, instead of just pulling the plug. So that's how the kind of higher level controller here controls this. And we're also passing in a polling interval. So we get our queue name from our app settings. We start our service bus client, calling some helper function, get client. We create our service bus receiver. We're going to have our timeout, time span, and then here we are starting the message pump. And here's the loop. While, this basically means while true, but until keep looping until someone signals that I want you to cancel. So there's the loop, and within the loop, we say message equals await receiver.receive message async with the timeout. And this creates a natural polling interval if there are no messages. So let's say there were 12 messages in the queue. You would get the first one, process it and loop. Get the second one, process it and loop. And it would spin through them all. And while you were processing, if another 3 or 4 came in, it would keep chugging away. And eventually it might run out of messages. So if our polling interval was 10 seconds, then it would just pause here for 10 seconds. And if no messages came in, it would loop and it would try again. So that way you're not creating a tight spinning wait loop. And you don't have to use task.delay or anything like that. This just gives you a natural cadence. So if we got a message, then we're going to do something with it, process it somehow. And then when we're done, we complete it. And in this case, I've implemented with an exception, we're just going to log it and abandon it. So that's a message pump, really lovely pattern you can implement. Another option you have is to pull more than one message at a time. You can pull batches. So to do that, you define your batch size, whatever it is, and you call receiver.receive messages async, telling it the batch size and the timeout. And this gives you a read-only list of service bus received messages. So how does the batch work? Let's say there were 15 messages in the queue and your batch size was 4. Well, you will never get more than 4. So you might get 4, and then the next 4, and then the next 4, and the next 3 to get up to 15. It also might give you 4 and 4 and 3 and 3 and 1. So just because your batch size is 3 doesn't mean you will always get 3, even if there are 3 available. But it does mean you will never get more than 3. So batching is cool. If there were no messages in the batch, then this loop would do nothing. But if you got some messages back, you could loop through them and process them. So this is very popular, but it has one major gotcha that you need to know about. And that's this: when you call receiver.receiveMessages async, that starts the peak lock timer for all of the messages in the batch. So let's say your batch size was 10. And let's say under normal circumstances, it takes about 3 seconds to process each message. Whatever process message is doing takes 3 seconds. Well, your default timeout is 60 seconds. You got 10 messages, 3 per message, means you can get through them in 30 seconds, and there's no problem at all, right? No problem. You have 30 seconds of headroom. Now let's say process message is depending on some other server or service, and it's having a bad day. It's laggy and slow. And instead of 3 seconds per message, it's jumped up to 7 seconds per message. So now what's going to happen is the first, boy, I got to do some math on the fly, right? The first 8 messages may make it. But then that 9th message, it's going to have crossed over a minute and it will have timed out. And so when you attempt to complete it, you're going to get an exception saying you can't complete that message. It's not yours anymore. It was abandoned because your lock timed out. So you have to be careful when you use batches to make sure that your batch size, your processing size, and your peak lock timeout, not this timeout, but the peak lock timeout, that those all add up in such a way that you're not going to, like on a bad day, start getting good messages expiring. And then what happens is they expire, they go back in the queue because it's abandoned, then they come back and the next receive pulls them again, and then they retry. And that happens 10 times, and it starts snowballing usually. And so what happens is your receiver is just churning, retrying and abandoning and retrying and abandoning, and then they start dead lettering. And you come in the next morning and you're like, holy moly, why do I have 28,000 messages in the dead letter queue and all this activity last night that did nothing? So you want to be a little careful with batches. Sometimes it's called prefetch, is another term. Okay, the last receiver pattern is the service bus processor. And this is an amazingly lovely helper class that comes in that NuGet package. And it actually wraps one or more receivers. So this basically implements all that message pumpy type stuff for you, and it exposes it just through some events. So the way you do this is you say client.create processor, giving it the queue name, and then you wire up 2 events, and a process message async event and a process error async event. And then you tell it to start processing. Now, when a message comes into the queue, your process code just runs right here in the event handler. And if you are using peak locks, you don't even have to complete them, because when it gets to this last line here, this curly brace, it will actually call complete for you. It's kind of like an auto-complete feature. So this is really lovely. And then if there is an error, if something in your process message throws an exception, then you'll get the error handler. So if you just go on Microsoft Learn and look for a Service Bus tutorial, this is what it's going to teach you. Or if you ask GitHub Copilot to write you Service Bus code, this may very well be what it suggests. So it is very lovely and easy to use. I like to work my way towards it from the kind of lower level perspective so that you know what it's doing for you under the hood. Okay, so if I stopped right here and we all went home, maybe you're already home, that you could probably put together a reasonable Azure Service Bus application. But it would not necessarily be industrial strength. It would not necessarily be fault tolerant and be ready for the real world. So the last thing I want to talk about are 2 real world situations that you need to know about and plan for in order to make kind of an industrial strength service bus application. And to explain this, I'm going to use just another little example so we have something concrete. So imagine you have a weather reporting thing where you've got weather stations out in the field taking measurements, and they are sending weather reports that get fed into this weather report queue. They get collected in here. So this is a really common pattern where it funnels down. Multiple senders funneling down into a single receiver is a pretty common pattern. The kitchen example we talked about is a fan out, where you have maybe one queue coming in and then it fans out to multiple receivers in order to scale that way. But you can do either. So what does this weather report processor do? It picks up the message, and we're just going to simply say its job is just to write it into a SQL database. So that's our app. So the first thing I want to talk about are poison messages. A poison message is a message that cannot be processed. It's just a bad message. So for this code, we're using our service bus processor. Here's our on message received event handler. And in the event handler, we read the body, which we're expecting to be some JSON. We deserialize it, and then we're going to do some more stuff to it after we deserialize it. But before we get to that, what happens if the JSON in the body is not valid JSON? Anybody know? Somebody go off mute and tell me. What happens here if the JSON is bad? Anybody?
Throws an exception.
That's right. It throws. This will throw. And I don't care how many times you try, it's never going to work, right? You can try this 1,000 times. It's never going to deserialize. So that bad JSON is a kind of poison message. Now, why did you get it? I don't know. Maybe the sender was on a different version of the software, or the sender has a bug, or somebody's being malicious. I don't know why it's come in, but it has. And so you've got this poison message. So if you don't do anything, this throws, then you're going to log the error and it's going to abandon. And then it's going to come right back to you. And you're going to hit that same message again. And then it's going to log it and abandon it. It's going to go 10 times, right? Which is a waste. You do not want to retry these things 10 times. So the way you need to handle this is, so this is poison message solved. And this is just an illustration of the idea. In this case, I'm catching the JSON exception. Right here, this would be a try catch. And when I catch the JSON exception, I'm like, that's poison. And then I dead letter it straight away. So that's the technique, is know what kinds of things will be poison messages, figure out a way to identify them. For example, typed exception handlers, just one way. And then dead letter them. Don't let them abandon and retry. Just get them out. You can't stop them from being sent, but you can put them in the dead letter queue right away. So that's the first thing you need to do, is dead letter your poison messages. The second thing that I want to talk about, the second problem, real world problem, are transient error conditions. So almost all of our complex systems like this have dependent services, and sometimes those can go offline. So here we have, again, this is just continuing our implementation of our on received event. So we deserialized the JSON. That worked this time. Then we create a SQL connection and we open it, and then we're going to write to SQL using that connection. So again, what happens if SQL Server is down? Oh, that throws an exception right there as well. So this is really different because this message is good, right? It's a good message. You just can't process it because your dependent service is down. So if you don't do anything here, what's going to happen is it's going to throw the exception, it's going to abandon, and right away you're going to try again. And you're going to hit that SQL Server again, and it's not going to work. And this can snowball because a SQL Server connection is kind of a simple example. But what if the problem is some sort of REST API or something like that? And now that service is trying to restart, and you're DDoSing it with all these requests coming in, right? So what you want to do in this case is stand off. Recognize the thing you need isn't there, back off and wait. Like, get everyone out of the pool until the thunderclouds clear, and then you can go back in. So how do we implement that? So here's our try, all that same code to process the message. And in this case, I'm catching the SQL exception. Stand off and try later. And in this case, I want to abandon the current message. That's good, right? We want to try again. That was our canary in the coal mine, but we don't want to just get rid of it. So we put it back for later. And then I'm pausing the processor. So here we call await processor.stop processing async. And then I'm launching into a little infinite loop here, a 1 minute polling loop that tests the SQL connection. And if the SQL connection works, then I restart my processor and I call break to break out of this loop. So this is our, basically back off, monitor the situation, and let everybody back in when it's safe. So those are your two kind of real world problems. And if you don't implement these correctly, the pattern you'll have is like the dead letter factory anti-pattern. And this really, truly happens where people come to work in the morning and there's hundreds of thousands of messages in the dead letter queue. They're all good messages. They've all been tried a million times, and you have to somehow replay them, and it's just not a good way to run this kind of app. So those are the things to look out for. All right. I added this slide recently. I don't want to, because it's always a question that gets asked. I don't want to spend a ton of time on it, but it is important to acknowledge that you have Event Grid, Event Hubs, Azure Service Bus, and Azure Storage queues. You have 4 different QE, eventy type things in the Azure ecosystem. And the question is, what's the difference and which one do I use? Now, I am not an expert on Event Grid, Event Hubs, or Azure Storage queues. I copied this straight out of Microsoft, learn.microsoft.com. There's one article called Compare Messaging Services and another called Azure Service Bus and Azure Service Bus queues compared and contrasted, that can kind of break this down. But the key thing here is, what is Service Bus for? It's for this use case of high value enterprise messaging, where guaranteed delivery and structured retry and strict FIFO ordering, where those things are important, right? We're not just broadcasting. These are the high value glue in a distributed enterprise system. So like order processing and financial transactions. So that's what this is for. There are the other ones. Maybe at some point I'll have a chance to learn them and I'll do a different talk. But that's where Service Bus fits into this ecosystem. So let's wrap up. At a high level, a messaging system is a fairly simple concept, and Azure Service Bus makes it easy to set up the queues and send and receive. But when it comes time to build a real one, you've got some choices to make. Are you going to use just basic queues, single receiver queues, or are you going to use topics and subscriptions in some kind of pub-sub sort of model? Using heavy or light messages, and why? Are you going to go with the default peak lock, or are you have a real use case for receive and delete? Are you going to use the Service Bus processor or roll your own message pump? And I should mention there's even another option, which is an Azure function that uses a trigger on a Service Bus queue. And I do have a YouTube video that illustrates that receiver pattern as well. So are you going to pull one message at a time? Are you going to use batches? Are you going to enforce strict FIFO ordering? Or are you going to allow like multiple receivers so that maybe the messages could kind of come out and go back and you might get some things out of order? And do you have a good strategy in place for poison messages and transient error conditions. So those are the things to think about in order to build a really good Azure Service Bus solution. All right, we're going to do questions and answers here, but I do want to say I would love to connect with you all. You can get me on LinkedIn. I have this YouTube channel, C Artisan. So if you find me amusing, you can go there. I'm not making money off that. It's more just about community. And so if you like what you see, please do like the videos, make comments, and subscribe. And what that does is it just helps other people like you find the content more easily. So I love getting new subscribers. And everything I've showed you today, I have a GitHub repo that you can go to, C Artisan Azure Service Bus demo. It's a little command line utility that illustrates absolutely everything that I went over. So that's how we can get in touch and continue the conversation. But for now, let's do questions and answers. I'll stop sharing unless we need to go back to the slides, and you just chat a little bit, see what people think.
All right, thank you, Matt. Any questions?
I had one question regarding the issue with the batched processing, where if you have like one message going back to the queue, what's causing the snowballing effect there? Is that just the producers out producing the consumers?
That's right. That's a really good way to think about it, right? You've got normally the bathtub drains at a certain rate, so there's certain, you can turn it on to a certain level and it'll drain out and never overflow, and that works until there's some back pressure, like what's causing the bathtub to not drain, and then eventually it can overflow. And in this case, when they overflow, they go back in the pipe, right? So
Okay.
Usually, in my experience, this happens because there's something downstream which is just not performing the way it did, the way you expected, and you hadn't quite planned for the worst case scenario.
Mm-hmm.
That's all. So there are third-party tools that use prefetch by default. You can easily get into scenarios where you're pulling 100 messages, and then it's basically kind of people don't understand what's happening. So now at least, if this kind of thing happens, you can be like, oh, wait, maybe it's prefetching, and maybe these locks are timing out.
Mm.
And then maybe it's a simple matter of like figuring out to extend the lock timeout. I think that's an easy way to do it. There is also the concept of lock renewal. That gets very complicated because then you have to have a thread that's monitoring how much time has expired and figuring out, oh, I better renew those locks. And that the talk last night, Dustin Kingan, who organizes the Detroit group, says he has implemented that, and I would love to see it because it sounds complicated to me. Anyway, yeah, that's kind of, your question is spot on. I think you've understood it. Yeah.
You may have said it, but in those batch processing ones, that example you had of bringing in like 5 or 10 messages at a time, with that timeout, if you don't receive 10 messages, will it take whatever you have in there, or will it wait for the number?
Oh, so two different timeouts, right? There's the receive timeout, which is when does my await, when does it move on? When does the continuation get cleared if there's no messages? That's totally separate, right? And then there's the peak lock timer, the peak lock expiration. So that peak lock expiration just applies to the one or many messages that you got in the receive.
But if I have a really slow like message production and I say I want to get 10 messages, but it takes me 2 minutes to get 10 messages, and I have that timeout set to 5 seconds.
No, it's only going to give you what's in the queue. When you call, it doesn't fill up to 10.
It doesn't. Okay, gotcha.
Yeah,
I didn't know if it waited till it got to 10 and then did it. Okay.
No. So let's say your timeout was 5 seconds on the receive, and there were no messages in the queue. It would wait 5 seconds and then give you an empty set.
Yeah.
All right. And let's say your timeout's 5, your batch size is 10. and there's only 3 messages in the queue. Well, you get the 3.
Gotcha. Yeah, that's why I make sure I understood. Thanks. Okay.
Yes, that's right. Those are, you've got it. You've understood.
Cool. And I appreciate the failure conditions, the part at the end there about the just showing the patterns. That's really like good stuff. So I really appreciate that a lot.
Yeah. That's the stuff that you don't get so much on like a lot of tutorials, right?
Exactly. Yeah. You see a lot of and I think that you covered the beginning was really good to cover that, but it's that part where you say, okay, now you want it to production ready, and that's the kind of stuff that I think was really a really valuable part to me. So appreciate it.
Yeah. So it's funny. Everyone asks this. This is a question about logging exceptions. So basically there's 2 paths, Rich. Like whenever, I'm assuming you're logging, right? Your app has tracing and logging. And that if there is an exception, no matter what you choose to do with it, you're probably logging that in some way. Whatever your log technology is, Serolog, App Insights, chucking it in a text file. So you want to log errors and exceptions regardless. When you dead letter those messages, the whole message goes in the dead letter queue. And what some people do is then they'll correlate and they'll be like, okay, here are all the messages in the dead letter queue. I have their correlation IDs. Let's go pull the logs and see what happened and figure out why they're in there. And so you can do your forensics, like go look at the message, figure out what's happening. Yeah, you would have to do it though, right? This is where the correlation ID helps, because the correlation ID stays on the message. And so as long as your log entry contains some data that allows you to go find that message, you can kind of correlate it and figure it out. But you're not going to put it's like you can't package the exception with the message, right? The message is the message. It came to you from the sender. So you can't like add stuff to it. It just goes to the dead letter queue as the message. Right. Now, you could set up an error logging queue. Sure, you could create your own queue called errors. And then anytime you want to handle an error, you could take that, you could make yourself a new message, which is like a copy of the old message plus your additional error stuff. You put whatever you want in the body, right? So your body could be original message plus error. And then you chuck that in your special error queue. But that's just another application, right? That's not like part of the Azure Service Bus thing. You're just making creative use of Azure Service Bus to use it as your log. Yeah, so logging to databases is common. I would suggest, if you're doing this, use Azure App Insights, which is kind of the built-in Azure logging thing, because it's integrated. It's kind of integrated in, and especially if you're like using Azure Functions to spool this up, you get all the dependency injection syntax for configuring the log, so that if you're running locally, it logs to the console, and if you're running in Azure, it logs to Azure App Insights, and however, right? It becomes it's a little like the ASP.NET dependency injection stuff. So this just depends on the nature of your app. But I agree. The only problem with logging to a database is if the problem is you can't get to the database. That's something everybody's nodding. They're like, yeah.
Been there.
Yeah.
Been there, done that.
What do you, for local development in general, do you tend to mock the service bus, or is there do you run against Azure directly, or is there any local emulator?
Oh no, I'll set up dev queues on Azure.
Yeah, okay.
Yeah, I run all of this code locally on my computer.
Mm-hmm.
But the actual queues will be, I just have a little Azure subscription where I set up my dev resources and do that.
Nice. Okay.
Yeah, you don't want to mock the service bus. It really, that I don't know how you would do that. You'd have to be very clever in your code to using like an you have to have your own interfaces of like IQ and IQ receiver, where you could sub in your own like fake implementation of this.
Yeah, I just think for like unit tests and things like that, sometimes it's handy to have something that you can use to like just say, acknowledge that you sent a message, not that, you got it's right or whatever, And so I didn't know, like a lot of time you're right, like I would use like some kind of my own abstraction to those, but I don't know if it makes sense in all these cases or if Azure offered anything that allowed you to.
Yeah, I haven't seen that. In the projects I've done, we literally just set up, we would have our dev data, our dev for our levels, right? Or like you've got whatever, dev, UAT, or dev, QA, UAT, prod. We literally have a set of queues at each one.
I gotcha.
Just a complete separate set of queues. And the only thing that is get complicated if you have multiple developers, I have set it up where we created, each developer had their own set of queues so that they weren't stepping on each other's toes.
What about the actual messages that you go between the services? Are you setting up like a separate repository for the schemas and their versioned and things like that to
yeah, that's a great. So this is your basic API question. Like forget messaging for a second, right? Let's say you've got a REST. Rich really just wants to do stand-up. That's good. So let's say you have an application that uses a REST API, and you actually own both sides of it. You're publishing the server and the client. Well, it's kind of like, I actually have these C# data classes that are used by both things. What do you do? And sometimes people put them all in the same solution, and there's a shared DLL. Sometimes people publish them as a NuGet package that both things can use. And sometimes people keep them separate, and just somebody's job is to, there you have a process, which means if I change it here, I have to change it there. And there's 2 copies of it.
Yeah.
But this only comes up into play when you own both sides of the equation. If it's just like a public REST server, then all you've got is the documentation and the Swagger, and you make your best guess, right? Or if it's SOAP, you import the WSDL, right? That's formal. Or if it's gRPC, you go get the proto file. So things like SOAP and gRPC are formal about this, and you have to publish the thing, shared standard.
Yeah.
In this case, this is a lot more loosey-goosey. Like, yeah, there is a message standard here, and the client better know about it, and the client and the server better agree. But Azure Service Bus doesn't contain anything that facilitates that.
I mean, you have the standard, you said the top level parts of a message that you can count on, those 8 fields, I think you said, something like that come through.
Yeah.
But on that, it's like how you serialize and deserialize it. And
you have a subject and a body, that's it.
Okay.
Yeah. To use as you want. Exactly. It has no opinion at all about what's in your subject and what's in your body. The only 2 things that it has an opinion about is you ought to have a correlation ID, and there's eventually a size limit.
Okay. But Service Bus itself doesn't have anything in it that says this is what the message will be to the consumer, so it can go in and create the proper message on local or anything like that. So, okay.
I've never seen that. No.
I think I saw it. Probably where it was. It might have been like Event Hub or something, but I thought that one of them had something that was like some kind of contract or something like that you create.
It wouldn't surprise me if Kafka does this, right?
Yeah, maybe.
So, but no.
Yeah, just curious how you've done it and things, so it makes sense. There's a lot of different ways, I think.
It gives you the spinny thingy, but it doesn't care if they're handwritten or typed out. It doesn't care if it's enchiladas or dal makhani, right? It really doesn't have any opinion on what kind of restaurant you're running.
Yeah.
So
nice.
A ticket wheel. Okay, a ticket wheel. I like calling it a spinny thingy, but okay, ticket wheel. You can tell that when I was younger, I just was the dishwasher, right? I never interacted with that thing. They just kept me safely in the back with the Hobart and the high pressure sprayer and told me to just stay away.
All right. Any more questions for Matt?
All right, guys. Fantastic. Thank you so much. I had a great time. And I'm really glad to have gotten to do this like tour of Detroit, of Michigan, greater Detroit area.
Thank you.
I wish you all a happy
great talk.
Thank you, Matt. So there is a link in the chat for the survey. We'll put it out there again, just in case you happen to have gone by it. And I will also email that out as well. I'll leave that open for about 24 hours to collect feedback, and then I will get you a copy of the results there, Matt. So, all right. Thank you very much, everybody. Have a great rest of your day.
Thanks.
Thanks.